Today we're going to talk about lesson 4-1, storing data into matrices. And when they talk about putting our data into a CAS, actually we're putting it into a TI 83 calculator or 84 or whatever you have. But why do we use a TI 83? It's because you can use that on your ACT test and it's going to help you out down the road. So the big idea is a variety of types of data from numerical information to coordinates of points can be stored in matrices. Okay, so we're going to look at matrices, and I want you to understand the fine little things about matrices and how they can be set up and so forth. A rectangular arrangement of objects or numbers is called a matrix. The plural of matrix is matrices. Notice how it's spelled. Each object in a matrix is called an element of the matrix. Matrices are useful for storing data of all kinds. For example, the median salaries of collegiate head coaches for 3 different sports based on the highest degree and institution grants are shown in the matrix below. Entries are in dollars. So if you notice here, they have row 1, row 2, row 3. Okay? They have column 1, column 2, column 3, column 4. So if you're a football coach with a doctorate, it says here you're making $185,000. Granted, you're making a lot more than that nowadays, but let's just go with it. If you're a football coach at these universities and have a master's, you're making $72,000. You got a bachelor's, $62,000, and an associate's, $31,000. And so forth. If you're a baseball coach, you're making that much across. Basketball, that much across. Okay? What you should note is each one of these things inside here, all these numbers, and I'm not going to circle them all, but those are our elements. A matrix is made up of a bunch of elements. Okay? Now, how do we distinguish the size of a matrix? Well, we call this, it goes rows by columns. So my dimensions for this matrix, how many rows do we have? Well, we have a 3. How many columns do I have? We have 4 columns. So it's a 3 by 4 matrix. Now, to identify elements, what you have to do is, normally what we do is we call this matrix something, and normally it's a capital letter. So I'm going to call this capital letter S. And why I'm going to call it capital letter S is for salaries or whatever. Okay? So if I wanted to find an element, what you use is little s. Okay? If this was called matrix A, you would use little a. But say, for instance, I wanted to find element 2, 3. That's not 23, that's 2, 3. That means row 2, column 3. So you go to row 2, column 3, and your answer would be 41,105. Okay? If I wanted to find element 3, 4, I go down to the 3rd row, 4th column, and you would tell me that is 45,982. Now they're going to talk about a little bit about the dimensions on the next page. Dimensions. The element of the above matrix are enclosed by square brackets. Sometimes large parentheses are used in place of the brackets. This matrix has 3 rows and 4 columns. Because of this, it is said to have the dimensions 3 by 4, written as 3 by 4. I already showed you that. In general, a matrix with m rows and n columns has the dimensions m times n. I like to use r times c. Why? Rows by columns. Okay? Each element of the matrix is identified first by its row location and then by its column. Okay, we talked about that too. For an example, the element in the 3rd row and 2nd column is matrix of this matrix is 63,343. You can go back and check that. Okay, 3rd row, second column, third row, second column, 63,347. Okay. Headings are placed outside the matrix, like the sports and degrees above. Okay. The headings don't mean anything to the matrix. Okay. It just keeps everything in order. A rectangular block of cells in a spreadsheet also constitutes a matrix. Spreadsheets use the reverse order for identifying an element. Column first, a letter, and a row second, a number. Like matrices, spreadsheets can have headings to identify their rows and columns. Okay. Example, it says, according to the Statistical Abstract of the United States, in 1980, approximately 3.5 million males and 1.9 million females participated in the high school athletics program. 10 years later, 3.4 million males and 1.9 million females participated. In 2000, 3.9 million males and 2.8 million females participated. A says, store the high school athletic participation information in a matrix. So I'm going to make a matrix. And the first bit of information that they told me was my years, right? So I'm going to put my years as my rows. So I got 1980, and then 10 years later would be 1990, right? 1980, 1990. I might have to make it bigger. And then 2000. So I have 3 rows, and I'm going to leave this open here because my numbers might be needing to be spread apart. But then what I'm going to do is I'm going to put males and females because we have so many males in 1980 and we have so many females in 1980. And I want to keep those separated. Okay? So how many males did we have in 1980? Well, we had 3.5. How many females? 1.9. How many males in 90? 3.4. How many females? 1.9. How many males in 2000? 3.9. Females? 2.8. And notice how this matrix keeps these numbers organized. So you know in 1990, how many females were there? Well, there was 1.9. And we know that this information, males and females, should be in millions, right? Okay? So there's a matrix. B says, what are the dimensions for the matrix? Okay? What are my dimensions? Well, it's a 3 by 2, rows by columns. It's a 3 by 2. C says, enter the matrix from part A into a CAS calculator and store it in its variable. I'm getting out my calculator. We don't have a CAS, but here's what you do. We're going to type this in. So, you hit second function, and then you see this little thing that says matrix. I click on that. Okay? Now, this is where a lot of people get mixed up at. As you see above, you have names, math, and edit. What we want to do is edit the matrix. Okay? So what I'm going to do is I'm going to call this matrix A, big A. So that's what I'm going to put it into my calculator. Okay? So I need to edit A. So I need to scroll over to edit. And I'm going to edit A, so I'm going to press the number 1. Now, as you see here, we're naming this matrix A. What size? This is your dimensions. Right now it says a 1 by 1. Well, we don't have a 1 by 1. We have a 3. Press enter. 2. Enter. Notice a 3 by 2 matrix shows up. So if that doesn't recognize the numbers, the same amount of numbers that you have on your paper or whatever, then you didn't do your rows and columns correctly. So now you just go through left to right and type these in. So 3.5, enter. 1.9, enter. 3.4, enter. 1.9, enter, 3.9, enter, and 2.8, and you got to make sure you hit enter so it's in there. How do we get out of this? We just type this into our calculator, so it's in there. As soon as we hit second function quit, now it's still in there. You can go back and check that. All you have to do is hit second function matrix. And now if you hit names, number 1, and hit enter again, notice it says I want to look at A. And there it is. Okay? That's how you type it into your calculator. We'll do more with those in the later sections. Matrices and geometry. Points and polygons can also be represented by matrices. The ordered pair x, y is generally represented by the matrix x, y. So you type in all your x's on top, all your y's on the bottom. So you're only going to have 2 rows, okay? And you can have any number of columns as you have points. But one point is going to go up and down, x on top, y on bottom. The second point is going to follow suit, x on top, y on bottom. And you're going to have a long strand of 2 rows, okay? It says this matrix is a 2x1 matrix called a point matrix. Or what you're going to hear Mr. Johnson call it is a coordinate matrix, okay? Notice that the element in the first row is the x coordinate and the element in the second row is the y coordinate. For instance, the point 5, -1 is represented by the matrix 5, -1. Similarly, polygons can be written as matrices. Each column of the matrix contains the coordinates of a vertex of the polygon in order in which the polygon is named. Okay? The activity illustrates this. We'll get to the activity. But why do we have point matrices? Well, you can use point matrices to translate images. If you remember in geometry, you should have done a whole lot of moving points to one section, up, down, left, right, reflection over the y-axis, reflection over the x-axis, all that fun stuff. Matrices give you a way to do that, and I should say, or reflection. Gives you a way to do that very easily just by using points. And we'll be getting to that later on in this section. Or not in this section, but later on in sections. So we're going to make a point matrix here. It says activity, matrix polygon application. Step 1. The pentagon ABCD with vertices A equals 3, -5, B equals 6, -1, C equals 4, 5, D equals -2.5, 4, and E equals -5, -0.75 is shown at the right. Write a matrix representing the coordinates of the vertices of the polygon, starting with point A. And that's what I always do, is I label my points A, B, C, D, all the way out. And if you start with A and work your way out alphabetically, okay, then you know you got every single point. So if you let's see here, they got A, B, C, D, E, okay? So here's my matrix, okay? Obviously, we know our X's are going to be on top, your Y's are going to be on bottom. You don't have to put this. I'm just showing you that my X's are on top, my Y's are on the bottom, okay? And then we're going to go across here, A, B, C, D, E. And I'm just using these as headers. It's not part of the matrix. These don't go inside your matrix. Only your numbers go inside your matrix. So, A is 3, -5. So you put a 3 there, a -5 here. B is 6, -1. 6, -1. C is 4, 5. D is a -2.5, 4. And E is a -5, a -0.75. You follow your steps how to put in that matrix, okay, into your calculator. This is a 2 rows by how many points do we have? 1, 2, 3, 4, 5. So this is a 2 by 5 matrix. So let's go ahead and put that in the B just so you get another practice. So you hit second function matrix. And I'm going to put it in the B. So I'm going to go over to edit. I'm going to press the number 2. And I'm going to do this kind of fast. So this is going to be a 2 by 5. Okay. Now remember, this goes left to right. So you're going to put in all your x values first and then all your y values. So it goes 3, 6, 4, negative 2.5. Remember the negatives down here. And a negative 5. If you use your subtraction key, it's going to give you an error. And then a negative 5, a negative 1, 5, 4, a negative 0.75. You hit enter, and you know that's in there. Hit second function quit. If I happen to want to look at it, second function matrix, press 2, hit enter, and there's my 2 by 5 matrix. Please pay attention on how to set this up. Please pay attention to what a coordinate matrix looks like. That's all I have for you today. Please enjoy. We'll see you tomorrow.